The question from JMN's 2021, it's also a pretty good question, where we have to go for the stereoisomers possible in 1,2-dimethyl cyclopropane. Now we know that this 1,2-dimethyl cyclopropane is this way, where we have this CH3 group and H, and then we have CH3 group and H, this way, right? Now in this 1,2-dimethyl cyclopropane, this carbon center is also chiral and this carbon center is also chiral, right? So we have two chiral centers. Now, if we have two chiral centers in a molecule, so the number of stereoisomers must be 4, right? The formula that we used to calculate the stereoisomers, the number of stereoisomers generally is 2 raised to n. But this is not applicable directly in those cases which have plane of symmetry. This molecule, that is 1,2-dimethyl cyclopropane, is having a plane of symmetry. Now, let's say that a plane is bisecting this molecule. We consider a plane of symmetry. Now, due to this plane of symmetry, the molecule can be dissected, the molecule can be partitioned into two equal halves, and both the parts of this molecule can reflect each other. So there is plane of symmetry, and due to this plane of symmetry, there must be the presence of a mesoform. So a mesoform must be there. Now, for those molecules in which more than one chiral center is present, and a plane of symmetry is also present, the mesoforms are also present. The formula to calculate number of stereoisomers in that cases, the number of stereoisomers will be equal to 2 raised to n minus 1 plus 1. So this is the formula where n is the number of chiral centers. Now applying this, we will have 2 raised to 2 minus 1 plus 1, which is equal to 2 plus 1, and that will be equal to 3. So the correct option will be 3 stereoisomers. We can also draw these 3 stereoisomers this way. The first one as shown, which is the mesoform, right? This is called mesoform since plane of symmetry is there. So this is called mesoform. So we have this mesoform, which is also a stereoisomer, though it is optically inactive. Now remember this is optically inactive. Due to plane of symmetry, this becomes optically inactive, right? Now the second we have this way, CH3H and then CH3H. The CH3 on the opposite side, and similarly a mirror image of this molecule in this way, where we have this HCH3 and CH3H. So these are non-superimposable mirror images, and we call them as enantiomers, and enantiomers are optically active. So we have two optically active isomers and one optically inactive form, which is called mesoform, and in total we have 3 stereoisomers in case of 1,2-dimethyl cyclopropane. So option D will be the correct option.